All right, here we go. So one summer I used this, I could never get this thing to work. I kept telling them how great it was, but then it never worked the whole term. All right. Oh, I don't know why I did that. Green's going to be our color anyway. Okay, so let's see. Solving systems. Oops. Recording, yes. Okay. Right. 1, graphing. 2, substitution. 3, elimination. So we did graphing and substitution last time, and what I was saying is that the question is going to be like on a test or a quiz is going to be, solve this system by using substitution or elimination, and then verify it by graphing. Hopefully you can graph stuff by hand, and then of course you can use Desmos if you haven't had. Hopefully you had a chance to practice that a little bit. All right. So today we'll talk about elimination, and there is actually a fourth method that they don't teach, but there is another way. But we'll do elimination. All right, and they call it in here, I think they call it the addition subtraction method. All right, but it's really pretty much known as elimination, and I'll show you why. So let's say that we have a system of equations like this. All right, and we could use substitution on that for sure, and we could solve for x and substitute. All right, but like I said, substitution is not really the best way in my mind. I think this way is actually the easiest way. So let's explain how it works. Basically what we're going to do is take either one of these equations or both and multiply them by some sort of a number, so that when we add, one of these variables is going to be eliminated. So it's going to be gone. So in this case, I'm going to eliminate this x here on the top. All right? And I'm going to do that by multiplying this by -4. All right, so when I do that, I get a -4x minus 12y equals -48. So I've multiplied every single thing here by 4. And mathematically I can do that because I'm not changing the equation at all, because of that golden rule you were talking about. If I multiply one side, I got to multiply the other. So as long as I do that, all I'm doing is just making this equation bigger. I'm not really changing what it is. If I graphed either one of those things, they're going to go right over the top. Okay, because one is just a multiplier of the other. So now I have these two things here. So I have this one and my new one. And look what happens if I add these equations. What happens to the x's? What happens to them? They cancel out, right? They're eliminated. That's why it's called elimination. Okay, it's because you're eliminating it. So the x's go away. I get a -12y here, and I get a -56 here. Remember, I told you a lot of times none of my things work out very well. Here's another good example of that. It's not bad though, because we're only dividing by 10. So we get y is 5.6. All right. So that's the idea behind elimination. Now I still got to find that point where they cross, and I only have y. I got to get x. So I'm going to substitute this back in. Now, fortunately, I don't have a really clean equation like in substitution where you just put it in and use your calculator. Here, you have 1, 2, 3 choices of where we're going to put that y. It really doesn't matter where you put it because you're going to get the same answer. Maybe I'll put it in this first one that I did. just because I think that's going to be a little bit easier for me. Alright, so I'm going to substitute that in, sub in y. Alright, and now I just got to go ahead and work this out. So I got to take 3 times 5.6, grab my, oops, not that, I didn't want that.
Like 17.8.
Yeah, there we go. Thank you. 16, isn't it?
Yeah, 16.
Yeah, 16.8. Okay, so then I'm going to subtract that. And there's my answer. So now I got to take 12 minus 16.8. Get the right thing here. What the heck? What is it? Yeah, negative 4.8. Okay, good. There's my point. Okay? So that's what I do. My whole goal is to eliminate a variable. And it doesn't matter which one, you just eliminate it. Alright? So let's try another one here. So let's go with 2x minus 3y equals 6 and 4x plus 5y. Take this up a little bit. Alright, so now we got a situation like this. Definitely not want to use substitution on here because we don't have, every one of these has a number in front, right? Has a coefficient, so using substitution would be not a good idea. So then we need to pick a variable to eliminate. Alright, so for sake, I'll let you start picking for a second, but let's eliminate the x up here. Because what am I going to have to multiply this equation by to do that? 2, right? So that's easy, I can do that. And notice what we want to do is multiply by a negative 2 so that I can just add them. Alright? So I'm just going to add them. So now I have negative 4x plus 6y equals negative 12. And then 4x plus 5y equals negative 12. Okay, so I'll add these up. This is going to be a real messy decimal. So here, again, what happens to those x's? They go away. So that's to eliminate. That's why it's called elimination. So then we're going to get 11y, because we're adding these equations, equals negative 24. And here's where I get this nasty decimal. But that's okay, because life is full of nasty decimals. 2.18 repeating. Okay, so now that I know what y is, right, I got to find x. And I have choices. I can go to this one, I can go to this one, or I can go to that one. Okay? And it really doesn't matter. I don't know. I have a negative 3y. Maybe I don't want to do that. Maybe I'll put it in this one this time. 4x plus 5 times negative 2.18 repeating equals negative 12. 5 times 2.18. Dang it. And I'll put a couple 1/8s in there just so I get it. 10.99. So I have 4x minus 10.09 repeating equals negative 12. And just add that. put a couple 0 9s in there. 1.9 basically is what it is. And then we got to divide that by 4. Man, this is a real nasty decimal. So we're going to get 4 something there. 0.4 I should say. Yeah, 0.475. And you can round it to 0.48 or something like that. Because you carried it out 2 decimals here, so you should probably go 2 decimals there. Right. But that's the idea. You know, we want to eliminate a variable and then get the answer and then solve it out. Alright? So let's do another example. I'm just giving you some different cases here. So let's try one like this. Okay, so now we have this situation. Now, there's not really a single number I can multiply by to get this. So, I'm going to pick a variable to eliminate. Alright? And then we can multiply both equations by something. So which variable do you think is best to eliminate here? And why?
Get rid of the 5x.
Okay, so get rid of the x. Yeah.
I was thinking getting rid of the y because you can do 4 and 3 to get 12 with that, and that'll cancel out.
Okay.
You could do it with 3 and 5 also and do 15.
Exactly. But what would be the difference if we eliminated the x's and you went with the 5 and the 3 versus the 4 and the 3? You see a difference?
Yeah, the 4 and the 3 would be better because the signs, positive and negative, so
Right.
it'll cross out easier if they're both 12.
Right. So see here you have a plus and a minus. So it would be easier for us to multiply to get rid of the y's. Right? Would it be wrong to do this one? Nope, not at all. It's just that you're going to have to multiply by a negative. Another chance of making a little mistake. Whereas here you don't have to. So that's good. So now we're going to multiply the top one by, what'd you say multiplying it by?
Multiply it by 3.
Okay.
And the other one by 4.
So this one by 3 and this one by 4. So you can multiply both equations if you need to. It doesn't make any difference. So here's what I'm going to get. We're going to get 9 and 12 and 36. Now make sure that you go through and do each and every one. There's times where I've seen folks, do this one and forget the last one there. Okay, so make sure you do the whole thing. Well, this is going to work out good. Okay, so then we have this. All right.
3 negative 4.
What's the matter?
Well, it's 3 times 3, but not negative 3.
Oh, what did I do? I got 15 here, don't I? I'm at 12. Sorry about that. Yeah, that one's good, right? Yeah.
Shouldn't it be negative 9?
Where?
On the top
We're
one?
not multiplying by a negative.
Oh, we're not. Okay.
No. We don't need to because this is a plus and this is a minus. Okay. All right, so now we're just going to add these, and the x's, we're going to get 29x. Y's are going to go away, and look what happens on this side. This is really nice, because that gives me 0. So even though we have a nasty 29 there, it doesn't matter because x is going to be 0. Right, so that worked out great. I wish I could say I planned it that way, but I didn't. Okay, it's just, right. So we got x equals 0. And now we just got to substitute that in. And now you have 4 choices. Here, 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 or here. You can pick any one you want. Anybody have a preference which one they like? Bottom one? The bottom with the 5x? Okay. Again, it doesn't make much difference, so we'll put it in right there. So we're going to get 5 times 0 is actually, we know what that is, but I'm going to write it out anyway, just so you know what you got. Wow, look at that. So that goes, and we're going to divide by -3, and by gosh, this one works out. And there's our point. Okay. Now, you know, I've taught this class a number of different years, or a number of different times, and I always like elimination, but then there's people who say, you know what, I think substitution is way better. Hey, if that's what you want to do, that's fine, because there's going to be times where I don't care how you solve it, you can use substitution or elimination. You get to pick. You know, for some of them I'm going to say, hey, do it by substitution, but do it by elimination. The other ones, I don't care which method you use. It's your problem. You just got to figure it out. So questions on the elimination part of those 3 there? Be careful of a couple of things. One, you might see something like this. I'm probably not going to do this problem, but I want to show it to you. Okay, something like this, where, see how they put the y here, and they're not lined up? So you got to make sure they're lined up, okay? Or else you can't do it. So be careful of that. You might see something like that where the book's trying to trick you a little bit. You know, you're working on this and it's late at night, you're trying to get it done, you know, and they throw something like that at you. So be careful about that situation. Also, they have some where they put it in this form. Something like that, where they line up okay, but this one has an equals and this one has a minus, so they're not in the right format. All right, so then we'd have to take this one and rewrite it so that it was 3x, move this y over, and then set it equal to -10. All right, now you can do it. All right, you can do this one by elimination. But you have to be careful because they will sneak those equal signs in there. If we did do this one by elimination, all right, we could just simply multiply this bottom one here by a -1. So that would be a negative, make this a positive, and make this a positive. So I could just multiply this by a -1, and then I could do it. So I'm going to have 1x. The y's cancel out, and I get this 22 here. Okay, so that's pretty simple. So see, you can do, even ones that look like substitution, you could do elimination on them, and they work out really well. Okay, so you got to be kind of careful of that. Other than that, I think that's pretty much. Do you have any other? Yeah.
The one before that, where they weren't lined up, if we had to do that by elimination.
This one?
Yeah. Would we just do it a different way besides elimination, or how would we do it by elimination?
Just rewrite the second equation so that it's 4x plus y equals 13, correct?
Yeah, we're just going to take and rewrite this. So the 4x is here, the plus y is here, and the 13 is like that.
Okay.
Yeah. Now you could do substitution on it because you got y, right? But I don't know. I just think elimination is a little better. That's up to you though. Now they're lined up. So, any other good questions about elimination? I'll promise tonight I'll give you some chances to do some. Now you will have some situations again, all right, where you're going to get no answer or a same line, okay, when you're doing things by elimination. So for example, let's say we have this. Alright, so if we have one like this, okay, and let's say we want to eliminate the y, so we have a plus and minus here. Okay, what are we going to multiply the top equation by then? -2, right? Okay, when we do that, then I'm going to get a negative 6x minus 4y equals negative 8, and you can see that that is the exact same thing that the bottom one is. Okay, so actually I don't need to multiply by a negative 2. I can just multiply by 2. I don't know why I did that. And now, this gets 0, this is 0, and this is 0. So everything turns out to be 0. So then 0 equals 0. So this would be the situation where these are the same lines. So we would go x comma y such that, and then just pick an equation to be your answer.
That could be any equation at all.
It could be either this one or this one.
Okay.
All right.
But these both of them are true.
Because they're the same line.
Okay.
Yeah. So if you get a situation like that, then that's what that's going to look like. All right. Staying with the same type of deal here. So if we have 3x plus 2y equals, I'm just going to change this just a little bit, and then you'll see the difference. So still multiplying by 2, we'd have 6x plus 4y equals 12, and negative 6x minus 4y equals negative 8. And gone, gone. So I have 0 equals 4, but does 0 equal 4? No, so that's a no solution. So we can still get a line, and we can still get no solution, and we still get one solution. Okay. That's how eliminations work with that. Anything else on elimination? All right, so for the next section we're going to do here, 4.4, all right? The always famous and wonderful word problems that most people enjoy. All right, I know, ooh, I heard them already, right? Okay, that's what this section's on, and they use systems of equations to set them up and solve them. So what I like to do on these is, hopefully kind of have a book with you. If you don't, we'll do the best I can here for you. We're going to go to 330, okay? And I'm just going to go through and pick out, or maybe even have you pick out some problems in each block. So in the syllabus, what I have is on page 330, I have 1 through 3. So in those 3 problems, they're all the same type of problem. So I was going to do one, and then you'd have one to guide you to do the other 2. And then 8 through 12 is another type of problem. So I was going to do one, and then you'd have that one to help guide you through the other ones. and the same thing for 15 through 21, and so forth. So we'll pick one out of each one of those little blocks, and then we'll do it, and then you'll have something to look on or to look at when you're doing the rest of the problems. Okay. There are a couple here where a system of equations doesn't work very well to solve it, so if we think of a different way, we might do it that way. But that's how I was going to do this. So let's work on it for about another 10 minutes or so, and then we can take a little break here, see if we can get through it, and then I can give you some problems to work on. So let's do 4.4, 330, 1, 2, or 3. Does anyone have a preference which one they'd like to see done? Which one?
Number 2.
2? Okay, number 2. So again, I just want to make sure we understand. So this is one of our homework assignment problems that we're getting. It's like a free one, right? So you want to make sure that when you're writing it down somewhere, you know, it's going to be one you're going to turn in to me. All right? So just as long as you know that. So number 2, what does it say?
The sum of two numbers is 5. If one number is subtracted from the other, their difference is 13. Find the numbers.
Okay, so we got two numbers, right? All right? So obviously we're going to let one number be x probably, and the other one be y. Those are my two numbers. Now what did it say in the first sentence? What does it say in the first sentence?
The sum of two numbers is 5.
Okay, so how could I write an equation to represent that?
X plus y equals 5.
Yeah, x plus y equals 5, right? Because sum means add, okay? So that's the first sentence. So that's how I'm going to attack these. These first three are all the same thing. All right, and then the second sentence says what, basically? One number is from the other, then we get 13. So what could we write for that?
The x minus y equals 13.
Yep, x minus y equals 13. Okay, so I choose x and y. You can choose a, b, and I don't care, m and n, whatever you want to be your variables, and then we just read it and say, okay, what exactly is it saying? And like I said, the other two, 1 and 3, are going to be very identical. So now you have something to go by. So now we have to solve this. What method do you want to use? We have 3 of them. Which one do you like?
Everything's probably pretty easy. I just do substitution.
Okay, that's fine. What variable do you want to substitute for, x or y?
I'd start with x.
In which equation, the top one or bottom? Which one?
Top.
Top? Okay, so you're going to solve for x. So then if we do that, we're going to get x equals, what are we going to have to move?
The y over
Okay,
y.
all right, sounds good. Okay, now what do we do from there? Substitute it in, right? Good. So we have 5 minus y equals 13. I know that's going to be 2y there. And then I just solve it out. So y is negative 4. And then I still have to figure out what x is, because we're still trying to find a point. Okay, but that'd be pretty simple, because we can just drop it right into that. So what does x turn out to be? What do we get for x? Nine? Good. Yeah, negative 4 dropped into here. 5 minus negative 4 is going to give us 9. Good. So 1 and 3, the other two in that block, are very similar to that. All right, so now, not only do you have one problem done, you also have something to go by as a guide. Okay? Questions on how we did that? Okay, So we did number 2. Now the next block is 8 through 12. And so they're pretty much, the 8, 9, and 10 are exactly the same, just use, well, not exactly the same, just they're pretty much the same, and 11 and 12 are the same, but they're kind of all in the same general thing. So which one would you like? 8, 9, 10, 11, 12, you guys can pick. Doesn't matter to me.
Let's do 12.
12 it is. Now, make sure you understand that for 8, 9, and 10, right above it, it says in exercises 8 through 10, refer to the bar graph. So you got to look at the bar graph above that, okay? So make sure that you read that little part there, because otherwise it's going to be confusing. All right, number 12. What do we got here? What does this one say? Doesn't matter who says it.
Restaurant purchased 8 tablecloths and 5 napkins for $106.
Okay.
Later, tablecloths and 6 napkins were bought for $24, for the cost of 1 tablecloth and the cost of a napkin, assuming the same price for both purchases.
Great. So that's awesome. So what's our variables going to be for this? What do we want?
Tablecloths could be T and the napkins could be N.
Sweet. Something different. So that's going to be table, napkins.
Then T could be your X variable and N could be your Y variable.
Sure, well we can stick with T and N too. You know, you picked it, that's a good idea because you know what they represent now. Okay, cool. So now we got to take that first sentence and write some sort of a mathematical equation for it. So what could, looking at that first sentence, what could we write?
It'd be like 8t plus 5n equals 106.
Good job. So 8 tablecloths, 5 napkins for 106. Okay, there's one equation. What's our second sentence telling us?
1t plus 6n equals 24.
Okay, 8 tablecloth and 6 napkins were bought for 24. Nice, good job. So there's our equations, right? So that's the hardest part, you know, is taking the words in the page, in the problem, you know, and writing an equation. That's the toughest part for people. Pretty much everybody can do this part, right? But it's just converting. So make sure, you know, take it slow. You know, I wish I had the magic formula or the magic thing I could say, you can solve every word problem if you do it this way. I don't have that, but I can just say, take it slow, read it, try to figure out what it's saying, and then go from there. All right. So we're ready. How should we solve this one? Elimination. Okay, good. What are you going to eliminate? Which variable? T. And you're going to do that by doing what?
Multiplying by 8.
Bottom one by
Negative.
-8. Awesome. That's a great idea. Okay, so now I'm going to go like this time. I'm going to put -8t here, minus 48n here. And then I need 8 times 24. I think that's -192. Yep. Okay, so now I'm going to look at, right, so I'm looking at this one and this one here. Okay. So what happens to the t's? Cancel. So I'm going to get a -43n, because I'm adding these two, equals -86. So then I can see right away, what is n going to be?
43.
What's n going to be?
No, 2.
2. It's all right. Yeah, it's okay. Huh?
Well, it'd be $2, I guess, but it would be -2 from what we did there.
If we divide both sides by a
I
negative.
didn't realize it was negative. Oh, yeah, I got the
If you do get a negative in a situation like this, then you should be concerned because you can't have negative, what is this, number of items or something like that, I think? No, dollars. I guess you couldn't, yeah, you couldn't have negative cost.
It's just sometimes it has, they do cost is negative, or it's like the money you have minus whatever, so.
Yeah, so if you're losing money or something, it would be called negative. Yeah, you're right. So now we know what n is. So how are we going to find t now?
Plug into the top one.
Okay, plug into the top one. Awesome. So we're going to go 8 times 2 plus 5n equals 106. So 16 plus 5n equals 106.
It's opposite, isn't it?
Yeah, you did the wrong.
Did I?
It's 8t plus
Oh,
5 times.
you're right. Sorry. I was thinking the top one, the very top one. So we're going to do this one. So we're going to go t plus 6 times 2 equals 24. So t plus 12 equals 24. And t equals 12. There we go. That was a good choice. Okay, so there we are. So 11 and 12 are kind of in the same. And 8, 9, and 10 are like this one. You just got to use that chart, that bar graph that's up there. Okay. All right, so we took care of that. Then our next block is 15 through 21. Again, these are all kind of in the same. 18 is not a very good example. I think that's the one. It doesn't even make sense to do it that way. But so 15 through 21. Anyone there you want to look at that looks like it might be, I don't know, challenging or whatever one you want? 15 through 21. 16? Okay. So number 16. So far this is our third one. All right. Oh yeah, okay. So what is that one? Somebody want to read that one for us? Doesn't matter who.
A rectangular lot whose perimeter is 1,600 feet is fenced along three sides. The expensive fencing along the lot's length costs $20 per foot, and inexpensive fencing along the two side widths costs only $5 per foot. The total cost of the fencing along the three sides comes to $13,000. What are the lot's diameters?
Great. This one's not quite as easy to write equations for because it's a little bit different. Alright, since it's talking about a rectangular lot and fenced along three sides, I think I'll draw a little rectangle here. So it must be put up against like a house or something like that because I'm only fencing in these three sides. There we go. Alright, so I draw a little picture of what's going on. I got the word perimeter in there. Okay, so what does perimeter mean?
It's all sides added up.
Yeah, it's the lengths of all sides added up, right? Cool. So then it's a rectangle. So if I make this side, I don't know, X just for the heck of it, how much does this side opposite have to be then? X, right? It's got to be. Okay. All right. Then I have another length. So what should we make that? Very good. So now I have a picture and I have some X's and Y's on there. Now maybe I can write an equation. So what does it say about the perimeter? How much is it? $20 per foot. But what does it say in the first sentence?
Perimeter is 1,600.
Okay. And so, what was your name? Thomas, right. So Thomas, he says that you would want to tell me perimeter was the length, added all those up, right? So if that's the case, then can we write an equation to represent this then? What's it going to look like?
2x plus y equals 1600.
Exactly. Okay, so 2x plus y equals 1600. Do we worry about this length over on this side here? No, because it's up against the house or something, right? So it doesn't matter. Okay, cool. We got one equation done. Now we're going to use the information that you were telling us. What else do we have about money? What's it say about the money? $20 per foot for the length. Is that what they're saying? Okay. So one of these is going to be a length, right? But I have to be careful because it's different. So let's see. I guess maybe length. Maybe the length is this way. I don't know. What is it? Does it say anything special about that? The expensive.
It's gotta be, the length has to be wide because it says the two side widths.
Oh, you're right. So then our length is going to be this way. So that's $20, and the two widths is 5. Okay, and then what's the whole money situation come out to be? Okay, so let's write an equation for that now. What would that look like?
5x plus 20y equals 13,000.
So so let's see, it's $5 per foot. So 5x plus, what did you say?
20y.
20y is equal to, okay, that's awesome. So see what we're doing here too
You're missing a 0.
is that, oh, I wouldn't want to cheat anybody there. Okay, so money, money, money. We're putting all those things together. Okay, so when you're writing usually a story or word problem and they're categorized into two different quantities, you always want to put those quantities together. So we have money, 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 and length, length, and length. Okay, now we're ready to solve this. So how do you want to do it? Substitution, elimination. What would you like to use? Elimination? What are you going to eliminate? Eliminate the y? Okay. So we're going to eliminate y. How are you going to do that?
Times -20.
So it times the top equation by -20? What a good idea. This time I'm going to go over here. Alright, so I don't get confused. So we get -40x minus 20y equals 32 with another 0. And it's going to be negative. Okay, and then the bottom one doesn't change. Because you said you were going to leave that one alone. Okay, and there goes my y's are gone. And my x, let's see, I'm going to get 0, 0, 0, 9, and 19. Negative. Okay, I sure hope 35 goes into this. Uh-oh. That's probably not a good thing. I wonder, x is the number of distances there. I wonder if we have to multiply that by, no, because it's x is the distance there and there. I wonder if this 5, I was wondering if that 5 would have to be a, well, it shouldn't be though, because it's just $5 per foot. Did we make a mistake somewhere? Did I make a mistake somewhere? 32, 5, 20, 13, 40, negative 20, 1300, 35, 32 and 13 is 19.
Two different types of fences, I don't know if that.
Yeah, I was wondering.
That's what the X and Y are, those are the that kind of fences.
Yeah, we covered that pretty well. 2x plus y equals 1600. I just want to make sure I got that. I don't see anything that I did wrong here. Yeah.
Maybe it's just purposely a big number in the textbook. You really never do that.
Usually they don't. going to try something here. 19000 divided by 3 equals. No, doesn't make any difference. Okay, I'm going to do it. So let's see, 19 is 1, 2, 3 divided by 35 equals 542.
So it'd be negative 542.85.
Which make it 9. But it's got to be positive because, again, we have a negative. And I just have this little squiggly negative there. And it's a length, so it's got to be positive.
Oh, yeah, it's negative. Yeah, so it's
So we got that. So then I put that in. Probably that top one there would be easiest. Times it by 2 equals 185. So it's going to work. We're going to get decent answers. They're not going to be pretty, but they're going to be decent answers. Minus, I forgot what it was. 1085. $515. How about that? That's pretty. 515. It was a 0.2. Okay. How about that? I don't know if it just turned out messy, I guess. But that's it. Alright, so 15's like that. And then 18, 19, and 20 are kind of in the same idea as far as the structure of it. Okay. Okay, let's hang in there and do one more, alright? So 29 through 32. Yeah, we can do that one. These ones are going to be better. Okay. 29 through 32, so you have 4 choices there. Which one would you like to do? 29 it is. These ones have charts that go with them, so they're actually a little bit nicer because they have the chart. So could someone just kind of read 29? I'm going to write this chart down here.
It says you invest $20,000 in 2 accounts paying 7% and 8% annual interest. How much should be invested in each rate if the total interest earned for the year is to be $1,520? Begin by filling in the missing entry in the following table. Then use the fact that the interest for the 2 investments combined must be $1,520.
Okay, so they're giving you this chart, all right, and they're paying 7 and 8%. And if you can find something that pays 7 and 8%, you better invest in it because I don't think there's anything out there that hardly does that. All right, these problems are definitely not realistic. Okay, so they put an X and a Y here, and they put a 0.07 here, and a 0.08 here. You see where those numbers come from, right? Here, change them to decimals, okay? And this is using the old P times R equals interest, principal times rate equals interest formula, okay? So then this is going to go here, all right, and this is going to go here. So it says you invest $20,000, all right, and 7 and 8%. Total interest is $1,520 after 1 year. So here's what we're going to do. Since X and Y is how much we're investing, I'm going to put $20,000 right there. And since this is my interest, I'm going to put my interest right here. Okay? So from that, we're going to get two equations, right? Because x and y are representing how much we're investing. So looking at just this part right here, okay, what equation could we write from that? Let's think about it. So we have x plus y equals 20,000. Very good. Okay, and then from this one, what could we write? Same idea.
0.07x plus 0.08x equals.
Yeah, that's right. There's my two equations. Okay. So these money problems are going to work like that. Every one of them is. Okay, so let's do it. So then what do you want to do? Elimination or substitution?
I think substitution might work better for this.
Okay. Substitution, which variable?
We could do y.
Okay. I assume you want this y.
Yeah, that y.
Okay, so then we're going to get y equals this 20,000 minus x. And this is going to go into, not there, there. Okay, here we go. 0.07x plus 0.08 minus 20,000 minus x equals 1520. One, two, three, four. 1, 2. Not too bad there. I get a pretty decent. And that's going to be 80. Subtracting that out of there. Negative. And then we're going to divide. And according to this, 8 should be about 8,000. Okay, so there's my money for that one. And then remember, we're investing 20,000, right? So if x is 8,000, then how much does y got to be?
12,000.
Yeah. I can back substitute it, but you don't really need to. Okay. So in these ones, and even in the mixture ones that are the next block, that we're probably not going to get to, they're the same. You're just going to fill in the little charts and go from there. Okay. So I don't know how many do I end up doing? 4 or 5 of them, right? Of each block, use those to guide you. If you can't figure them out, then come back on Wednesday and ask questions. You know, beginning of class, so we can do it. Okay. So what we'll do now is I'll let you take a break. When we come back, I'm going to put about probably 3 or 4 of the elimination ones for you to try and work on, and let you do those, and we'll work on those, and then we'll kind of see where we're at here. Okay. So go ahead and take a little break. Can someone want to tell me what we're doing elimination, so we don't have an option here. Which variable did we eliminate? Someone want to tell us what we did? Which one? Y. Okay. So if you're eliminating y, you're doing what to do that? Okay. Good deal. So that's 15 minus 5, 55, 2x plus 5y equals 13. Okay. So then what are we going to get here on the bottom part? Right down here. What's this going to be? 17x, good. Equals 68. And the 17 go in there?
Yeah.
What do we get for x?
4.
4. Okay. That's x, so we got to find y. So now what do we do?
Plug in that 4 into one of the equations on top. 2 times 4 plus 5y equals 13.
So then y turns out to be
0.
we can't get 0
0 right there.
in this situation then. That's okay, but we can't get 0. So we can get 1 though. You see how it's 1? Because you're dividing by 5 there.
Oh, that's right.
Yeah,
Yes.
okay, good. All right, let's try, let's see, the next one was 18. So 18 is 2x plus 3y equals negative 16, and 5x minus 10y equals 30. Okay, someone tell me what they did on this one. Obviously we're eliminating, so
I multiplied the top by 10 and the bottom by 3.
what are you eliminating?
Y.
Okay,
So I did that as 30.
okay, so then we're going to get this. And this. So then down here on the bottom, what are we going to get? 35. X equals negative 70. So what does x turn out to be? What are we getting for x? Negative 2, yep, good. Bless you. So we got negative 2. All right, and then how are we figuring out y?
You plug that into the top one.
Well, oh, yeah, okay, so that's going to give us 2 times negative 2 plus 3y equals negative 16. Okay, negative 4 plus 3y equals negative 16. So y is going to turn out to be, what's y turn out to be? I think you're right. Because when we add 4, we'll get 12, and then divide by 3, negative 4. Awesome. Okay, how are we doing so far? Getting them? Okay, good. Next one is 22. Okay, here we go. Okay, so what do you want to do on this one? Got to do elimination, because that's what it asked us to do.
We have to rewrite them.
Yeah, we got to rewrite this, right? Because it doesn't line up. Okay, so how do you want to rewrite it? So how should we rewrite this top one so it works for us?
Y equals 9x minus 25.
Isn't it 9x minus y equals 25?
Okay, so now, so we're getting two answers, and both of them are actually correct. We can go either direction if we keep it in the form of, you know, something. That's not very good. Something like this: x plus y equals x plus y equals. Okay, then that's what we want to do, right? And so, and you said, and what was your name? Aaron, you said, well, I think you said we just move that. What you said move though? What did you say? You told me again.
I said y equals 9, or make
Yeah.
it y equals 9x minus 25.
So then, in that case, we can line up the y's here, and we have y equals 25 minus 9x, right?
Correct.
And then everything would line up. Okay, so that would work. All right, so it just kind of depends upon how you want to do it. All right, a lot of times you're going to hear me say you got to find your way that works. So in this case, you got to find the way you understand and you can make it work. So if we do this, if we say, I just, you know, if you're one of those, you say, well, I got to have it. So that's just like every one I've been doing, or else I'm going to get all messed up, then that's fine. So we would move here. We could keep this. We could actually keep this here, but then we'd have to move this 4 over and this 2y over here. So that would look like something like that. Or we go with Aaron's idea, which was y equals 25 minus 9x, and 2y equals 4 minus 9x. So either one of these is going to give us the right answer. All right? You just got to find the way you understand how you want to arrange it. But we got to make sure we're consistent. See, this one's good. X, y equals numbers. This one's good. Y equals numbers, x's. That's okay. As long as they all line up, we're good to go. All right. So if we did this top one over here, what are we going to eliminate? This is an obvious one to eliminate. X. Do we have to multiply by anything? No. It's already ready to go. We have 9x minus 9x. So that's great. So we're going to get a negative 3y here and a 21 here. So what does y got to turn out to be? Negative 7, right? And then now I just got to figure out what x is. Okay? So I could put this right there. See how theirs always turn out except for that one hokey fence problem? There it is. Okay. But you would have got the same thing. Okay. So if you were going to eliminate, right? What would you eliminate if we did it this way? Yeah. The only problem is if this is negative, they're both negative. Okay. So we have to make this a positive. So if we go negative, negative, and then positive, we add them. We're going to get the same answer. Actually, we're going to drop out. We'll get a negative y equals whatever. So it should work out, unless I mess the signs up somewhere. Alright, but it should work out. Same one. Okay. Yep, that's good. Do I move that over? Yep. Okay. So we're gonna get the same thing. All right. So that's any questions on elimination? Then we did 3. You did some. We're good to go. Okay. So I know you're probably wondering what the heck you signed up for here, but I want to show you. I noticed something during a break here about our syllabus. So we can't do activity 1 until we do 4.5. So I'm going to move it down to here, and I'm going to change the date to the 29th. I'm going to post this syllabus for you on the DTL thing. Alright, so this will be a revised. That's why I put this in here, see? Any changes, syllabus could change, right? Or by instructor's choice. That's me. So, I screwed up, and so I'm going to move this down to here, which it actually kind of probably helps you out a little bit. So then we'll stick with the supplement here, and we'll do our quiz. And the supplement will take us like 2 minutes. Okay? And then after the quiz, you're done. But I'm going to move that down to here. Okay? Because we got to do 4.5 first. I don't know when I did this, I did put it in there. So, but I'll save this and I'll upload it before I leave tonight. So you got it. All right. The supplement. And I don't think we'll write this down and turn it in because it's pretty straightforward. It is, I'm getting it for you here because they're all in the book. I just got to find the darn things. That is, yeah, 4.4. So in my book it's on S25, way in the back. S, I guess, stands for supplement. 25 is the page. And it says supplement to 4.4 here. I can probably, let's see if I can master the document camera here. Oh, maybe it's on there. Let's see if we can get this one. I think it's going to happen. Maybe not. Uh-oh. Maybe. Maybe not. Never liked these document cameras very well. Okay. Well, I don't know, it doesn't seem to be connecting. Make sure it's connected to the PC. Well, I assume that it is. And there's no sphere thing on here. Let me just check one more time. Sometimes there's a software on here that makes it work, but I don't see it. So, I wonder if it's this guy. Oh, well. So, hopefully you're seeing it. Is everybody seeing it okay on their books? Okay? Alright. So here's the deal. So we got Hugo Reyes was mixing dried mango slices with dried pineapple to create a delightful island mix. Okay? So we got mango, that's $5.99 a pound, and pineapple, that's $3.99 a pound. So he's mixing this stuff, okay, to create some sort of blend. Alright? Question number 1A, and we're not going to write this down, we're just going to go over it, okay? Is it possible for Hugo to mix the fruit in such a way to create a mix that costs a total of $1.99 a pound? What do you think? I see some people shaking their heads. No, why not? Why couldn't you do it? Well, we're looking at price per pound, not total cost. So if the mango was $5.99 and the pineapple was $3.99, could he get a mix that was only going to be $1.99? No. Why not?
Because negative for either of the two numbers. So unless you're selling them, pineapples, but that's how it works.
Right, he's not selling it. Well, they're both higher than $1.99, right?
Yeah, the
Yeah.
pound wise.
Yeah, they're both higher, so there's just no way that can happen because both of those are higher. So part B, if Hugo mixed fruit and calculated that his mix would cost $4.80 per pound, which ingredient do you think he has more of? So what does he have more of if he mixes them and he gets charged $4.80 a pound? Which one's he going to have more of? Which one?
Have more pineapple,
Why would we have more pineapple?
because it costs less per pound.
Because it costs less, okay? So if it was split right down the middle, how much would it cost us? If it was split down the middle, how much would it cost us? Well, one of them is $5.99, so that's about how much? We rounded it. How much is that? $6, right? And if the other one's $3.99, then we round that, that's $4. So what's split down the middle? Split down the middle between 4 and 6 is 5. Okay. All right. So it's less than 5. So yeah, I would agree. He's going to have more pineapple. Okay, because it's less than 5. All right. See how these supplements are kind of weird, aren't they? If Hugo mixed fruit and calculated that the mix would cost $5 per pound, which ingredient did he have more of? Uh-oh, I just gave you that answer. If it's $5 a pound, they're equal. because we split it down the middle. If Hugo had a 5-pound bag of fruit that he said was worth $5.99 a pound, how much of each fruit did he add to make it? Okay, so this is a little different situation. So he's got a 5-pound bag of fruit that he said was worth $5.99 a pound. How much of each fruit did he find? Oh, well, let's see. Did he use any of the pineapple if it's $5.99 a pound?
The mango.
No, it's all mango, isn't it?
Yeah.
Yeah, because that's the cost of it. Okay, it's all got to be mango. All right. So, hey, there's supplement 4.4. We did it. Okay. Pretty crazy. All right. So I guess that's any other questions on anything before we do our 4-question quiz here and we're done for the night? No. Open mind though. You can use calculators, yes. What I said on here, I just said to when you're going to graph a couple of them, okay, and I said you could use decimals for 2 of them. So half of them you should graph by hand, and the other half you can use decimals if you want to. Okay? And when we're done, we're done. And I'll get that syllabus uploaded and the video uploaded. Okay? Which reminds me, I need to shut that off.